if I get one, let's say a rope, something like this, right? Let's say that blue line represents a rope. So if it is so, then so we can go for this dimension thing. For example, from here to somewhere there here need not to be the full length, right? So if it is so, then the length is going to be from there to there. For example, let's say is L, and the length of that particular amount of the thread or the rope or the wire or the string or the rope or the stud, let it to be something like simple M, or probably the M or M dash or whatever, it doesn't matter, fine. I'll say just the capital M, right? Right, fine. That mass is going to be capital M, and the length we selected was from here to there. This mass capital M is the mass of this length selected simple L. So therefore, if you write, that's going to be number 1. So if you write, okay, fine, regarding simple L, the mass is going to be capital M. So if it is per unit length, that's going to be capital M divided by simple L. Now, this particular ratio, the mass per unit length. Now, we had a simple L much number of mangoes price, that is going to be capital M. So per unit mangoes, one mango price, the price per unit, one mango's price is going to be just capital M over simple L, which is known as linear mass density, usually represented by symbolically simple M mass density. So therefore, simple M is going to be the mass per unit length. So therefore, I can write simple M is going to be equal capital M divided by simple L. There. Now, if I just get this one. So the M is measured by kilograms, obvious, and L being the length is measured by meters, obvious. So therefore, no problem. Simple M is measured by kilograms per unit length, kilograms per meter, / simple M or M minus 1. Now, if I make the object, the what's called the mass, the subject, mass is going to be equal to here simple M multiplied by the length. Simple M means one mango's price multiplied by the number of mangoes will give you the total price. So therefore, just one last thing regarding that. If it is the mass, capital M, this I'm going to make it the subject by taking that L to this side. Simple M dot L is there. So that's going to be the ultimate formula to be remembered. It's nothing, right? My brother, here capital M means the total mass. Total mass is equal to mass per unit length multiplied by the corresponding length. Okay, so put into the mangoes notation and just remember that this is going to be the price per mango multiplied by number of mangoes will give you the total price. For example, one mango's price is 10 rupees, number of mangoes 5, then 5 into 10 is equal to 50 will be the price of the total number of mangoes, which is 5 in this case. Total number of mangoes in this case, just we took that thing as 5. Okay, right, fine. So that is called this linear mass density. So I just write I think here, right? So linear mass density. Usually that symbol is going to be simple M. So that's going to be the thing. Fine. So number 2 is going to be something called planar mass density. Planar mass density, or sometimes we refer to that thing as the area density as well, and that symbol is called sigma, right? Planar, or sometimes we can just say area. So it's like planar mass density or area mass density. In that case, it's pretty easy. What we do is just we take one the object, okay, whose the, let's say, cross-sectional area, the entire this amount of area is going to be capital A, and mass is going to be sometimes capital M, and let's say linear mass density is going to be sigma. Oh, for the information I'll just write that is called sigma. Now you might ask, sir, but we have we have gone through sigma sometimes. That sigma is also there in my mind. Now it seems like that sigma is also haunting inside my mind. Like, fine. That is this sigma. I mean sigma, something like that. Okay, actually that is called the capital sigma in Greek alphabet, and this bugger is going to be the simple sigma, like capital A and simple A. That's the idea. So both are the sigmas. One is going to be the capital. That sigma is going to be capital sigma, right? I just write some other here. That's called the capital sigma, and therefore this is going to be the simple sigma. Done. So being back on the track, now if I get that capital A area, if it is capital A area, the mass of the object is going to be capital M. So I want to find one mango's price. So it's going to be capital M divided by capital A. So capital M divided by capital A is the mass per unit area. Mass per unit area. Mass per unit area R. By definition, mass per unit area is the planar mass density, or is area mass density. So therefore, we got the equation. The sigma is equal to the mass over area. Time to play the units now, and if I go for this one, the mass is measured by kilograms, no problem, and the area is measured by meter squared. So therefore, the planar mass density or the area mass density is measured by kilograms per square meters. Okay, that's it. So let's say I'm going to make that the M the subject, capital M the subject. Capital M is equal to then sigma multiplied by capital A, sigma dot capital A. So like as I explained last time regarding linear mass density, but again here number of like the price of the total number of mangoes is equal to one mango's price multiplied by number of mangoes. That's the idea. Here sigma means per unit cross-sectional area or just per unit area, probably surface area, right? It can be either surface area or it can be cross-sectional area. It doesn't matter. Usually it's going to be the surface area in most of these applications. But I think you have to remember it can be either cross-sectional area or the surface area. No matter what, depending on what they are going to give to you. So we can, just the manipulate. Okay, so that's regarding the planar mass density. And the next one is going to be the most important and most frequently used one. That is number 3. That's going to be volume mass density. Usually we say volume mass density. Volume mass density, symbolically represented by the letter rho. Okay, but simply we say density. right? Okay. The reason why when it comes to density, why we drop that volume part as well as mass and just we say density. In case you just hear the word density, usually you don't go for the planar mass density, or you don't go for the linear mass density, you just stick to volume mass density. What made that thing that automatic? I mean, when somebody says, or when you hear, it's like just the density, what comes into your mind is just the mass per unit volume. But when it comes to like density, sometimes when it comes to density, I think now knowing three types of densities, it can be, when we say density, it can be either the linear mass density, or it can be planar mass density, or it can be volume mass density. But the difference is when you hear the word density, what comes into your mind is, none of these previous densities, meaning it's not the linear density, it's not the area density. What comes into your mind is the mass density. Why? Because it's just like what we just do with the numbers. So what do you mean by with the numbers? Now, for example, let's say if I write just the 10 there, here, if I write just 10, and I'm going to ask, what is that? Because there can be two types. It can be sometimes the probably the what's called this positive number, or it can be a negative number. But I'm pretty sure if I write this one, and in case I'm going to ask from somebody, he or she is going to answer in a snap, it's positive 10, sir. Why? There is no question. Why you keep asking? It's positive 10. Why it's positive 10? Why we take that thing as positive 10? Because we know, in case there is no sign confronted, no sign is written in front of the number, that particular number is conventionally, it's not a rule, conventionally regarded as a positive number. Why? Because that is the number format. Positive numbers are the numbers which are most frequently used. Same point is applied when it comes to densities as well. Meaning what? Out of these three types of densities, linear mass density, volume mass density, and area mass density, the density which is most frequently used is volume mass density. So therefore, like the positive numbers, we just not going to bother about putting the plus sign in front of the number, but we know that number is going to be a positive number. Likewise, we just mentioned density, what it stands for, the volume mass density. That's the reason. Okay, fine. So then with that, we are back, and then we can just go for, let's say, the I'll take one object, and it's actually not the plain object. Likewise, some thickness is also there, like that, right? So let's say it's something like this. So it's just like a log, something like that. So then volume of that object is going to be V, mass of that object is going to be capital M, density, volume density is going to be rho. In that case, it's easy. If you take the volume V, the density is going to be, the mass is going to be capital M. So per unit volume, the mass is going to be capital M divided by V. So mass per unit volume, the definition of the volume mass density, or just simply density, which is represented by the letter rho. Rho. Okay. It's more just the P, which is kind of like knocked from this top. So it becomes inclined. It's just like P is vertically P. So somebody is going to knock from here. It becomes like that. It's getting a bit slanted. So have to be careful with these letters. Why? Because in case you are going to write that in vertical, usually that one is going to be the P, which is usually stands for what? Pressure. P stands for pressure. Okay. So is that, and then so we can write here we have the ultimately rho is equal to the mass divided by volume. Now game is over. You know what to be done. Playing with the units, mass is measured by kilograms and volume is measured by meter cubed, whereas the density is to be measured by kilograms per cubic meter, obviously. Why? Because the guy comes to the numerator. Cubic meters becomes per cubic meter. Fine. Okay. So density formula, rho is equal mass over volume, or density is equal mass over volume mass density. Actually, let's say now onwards. Let's say density. Density is equal to mass over volume is completely fine with you. But the terrible situation is sometimes you happen to find the mass of the object in terms of volume and density. So in that case, so you can use this formula. Okay. So how we can do that? I'm going to make that capital M the subject. So let's say mass will be made the subject. So by taking that V to that side, rho V, rho dot V. Fine. That's going to be the formula. Right. So number one, it is just the here we have total mass of one of these objects whose linear dimension dominates. So total mass is equal to mass per unit length multiplied by the length. And one object, for example, just like a sheet of paper, or just let's say it's a cardboard. The dominating dimension is going to be the surface area, not the length, not the volume. Half sheet එකක් ගත්තාම මේ half sheet එකේ කවුද දිග ගැන කතා කරන්නේ? කවුද ඒ half sheet එකේ volume එක ගැන කතා කරන්නේ? Those are auxiliary dimensions associated, but not the essential dimensions. Half sheet එක important වෙන්නේ the surface area එක. That's the idea. Get the computer screen. In case you're watching this video live session by using your laptop. Then screen is a good example for an object whose surface area is dominating. Then the length, then the thickness, they are there. Length is there, breadth is there, and the thickness, all these dimensions are there. But what is dominating? Meaning what becomes the greatest, the biggest, the surface area. So therefore, when it comes to even the laptop screen or laptop display, surface area is the one which is dominating. That's it. Okay. So when it comes to like mass, here mass can be expressed in terms of the density and volume. So therefore, the density into volume is equal to mass. Right. Okay. These are the three different types of the densities. So we have linear mass density, we have the area mass density or planar mass density, we have number 3, volume mass density, or simply density. Right. Time to save your screen, time to get a snapshot in case you are with me via the mobile. Okay, fine.